Okay, this is a quick review on how to do conversion problems when you're dealing with molecules to moles, moles to grams, molecules to moles. All right. So first thing you need to do is, this is a different kind of problem because I haven't set it up for you, so you should know how to set this up for your own. If I look, I know I want to go from molecules to grams, or grams to molecules. So the first thing I need to do is I need to know, okay, well, how many grams are in 1 mole of iron fluoride? If you actually take a look at this, we know that if I want to go from grams to molecules, if you look at the bottom, I have to go from grams to moles and moles to molecules. So the first thing I need to do is figure out how many grams in moles. So to do that, I want to put in a graphic. Okay, you're going to have to bear with me for a second. This should work out. There we go. All right, so I put in a graphic, and what I'm going to do is I want to figure out how many grams in a mole. So I know that I have iron, and if I look up iron's atomic weight, I find out that iron has an atomic weight of 55.8. And then fluorine, which is F, there are 3 fluorines. Each weighs 19, so I'm going to have to multiply that by 3. So 58.8, the weight of iron. Fluorine, 3 fluorines at 19 apiece equals 57. So the total weight of the molecule of iron fluoride is 112.8. All right, you can do that on your calculator. Okay, so now how do I solve these problems? Well, we've already talked about this. What's the first thing you do? You always write down what you were given. So I know I was given 12 grams. So this is the amount that I have. So I have to put down the information I know I have. Okay, so that's how much I was given. I was given 12 grams of iron fluoride. And then I say, okay, well, what am I looking for? What's the unit that I'm looking for? Well, I know I'm looking for molecules. So I want to know how many molecules are in 12 grams of iron fluoride. So I'm going to put that on the other side of the paper. And so then I have to figure out, well, wait a minute. If I'm going to go from grams, which is down here where it says mass, to molecules, which is a particle, all right, I can't go directly from grams to molecules. I have to go from grams to moles and moles to molecule. So what that tells me is that I'm going to do 2 conversions. I'm going to have to multiply by 2 conversion factors. Those are always fractions. So I'm going to multiply 1, and then I'm going to multiply again. All right, so the first thing I just say, okay, well, if I want to go from grams to moles, if you look at the arrow here, I know it's going to be 1 mole over the amount of grams in a mole. So let's actually take a look at that. And the other reason I know I'm doing that is because I want the label grams to cancel out, because that can't be in the answer, so I need to get rid of the number of grams. All right? Because that label is not in the final answer. That has to somehow cancel out. So the first thing I'm doing is I'm going to convert from grams into moles, which is the first step here. All right? Then the next thing I'm going to do says, okay, well, once I figured out how many moles I have, then I want to go from moles to particles, moles to molecules. All right, if you take a look at this, it shows you the arrows. Avogadro's number, 6.0 times 10 to the 23rd, is going to be on top. Moles is going to be on the bottom. So let's do that. 6.0, that's the number of molecules that are in 1 mole. Now, again, we know this is right because we want to wind up with molecules. Molecules is on the top here. Molecules is in the answer. Moles is going to cancel out. And then all I'm left is the numbers, and that's going to help me do the conversion. All right, so let's see what happens. When everything cancels out, first we cancel out grams. Grams of this, but divided by grams of that equals 1, so it just cancels out. Moles divided by moles equals 1, so that cancels out. So all I'm left is the number 12 times 6.02 times 10 to the 23rd molecules divided by the number 112.8, all right, is going to equal the number of molecules in this. So all I have to do now is I leave those numbers, and I say, okay, I got these numbers, 12 times 6.02 times 10 to the 23rd divided by 12.8. And if you want to do that, you can actually do that one way or the other. Okay. We're going to multiply the coefficient, so 12 times, 12 times 6.02 equals, and then we're going to divide it by 112.8, and that's going to tell me what the number is. My number is going to be 0.68. It's going to be like 0.66, um, 66, I guess. Let's see what I actually did. I think I didn't do that. All right, so, yep. Okay, so what we got is 0.64. That actually should be 0.66 times 10 to the 23rd molecules of iron. So actually, so what that leaves us is, the problem with that is not in correct scientific notation. So what I need to do is I need to convert to scientific notation. I'm going to move the decimal over, and so that means instead of 0.64, I get 6.4, which is larger. And then this number, the coefficient, the exponent has to go down so that we keep the number equal. All right, and that's basically how you do these.